Problem 5-74. Avery and Colin were still at it. Colin wrote t of 2 equals 19, t of n plus 1 equals t of n minus 2. Help Avery write an explicit equation. So explicit starts with t of n. Is the sequence arithmetic, geometric, or neither? So explicit, we start with t of n. So t of n equals, that's what we're looking for. So let's go back up here. We'll start with t parentheses 2. That again means our second term. So if I draw out my blanks again, first term, second term, third term, we know they tell us our second term is 19, so we can fill in that second term to get 19. And then if we go down here, t of n plus 1, I'm going to write again that that's the next term equals the current term minus 2. So our pattern is subtracting 2 every time. So if we have our second term, how could we get the third term? All we have to do is subtract 2. So that means our third term would be 19 minus 2, which is 17. But we need to go backwards actually. So if we're going backwards, we're not subtracting 2, we're doing the opposite, which is adding 2. So 19 plus 2 in order to go backwards would be 21. Okay, help Avery write an explicit equation. So explicit, we started with our t of n. We need to do our common difference, or kind of like our slope and linear. So our common difference is subtracting 2 every time. So we're going to do negative 2n. And again, make sure you write n instead of the x because we're dealing with sequences. And for after that, we need to put our 0 term. So what would come before the first term if we're going backwards? So if we add 2, since we're going backwards, we would get 23. So this equation would be plus 23. Okay, next part says, is the sequence arithmetic, geometric, or neither? Arithmetic is adding, and I know it looks like we're subtracting 2 because that's what it says, but that's the same thing as adding negative 2. So this one is going to be arithmetic. And I'm going to put that we're adding negative 2 each time. Okay, B. Then Avery wrote t of n equals 6n plus 8. Help Colin write a recursive equation. Okay, the 6n or 6, the 6 is our common difference. So this means we're adding 6 each time. That's our pattern. The 8 is the 0 term. 0 term. Okay, so in order to help us see this before we even write a recursive equation, let's write out what we know so far. So we know our 0 term. Our 0 term is 8, so I'm going to fill in 8. How would we get the first term? We would add 6 every time. So 8 plus 6, we get 14. To get our second term, we're going to add 6 again. So 14 plus 6, we get 20. Okay, this is going to help us for our recursive equation. We already had the pattern, but we needed one of the terms. Usually our first term is what we want to give them. So recursive, we start with t of n plus 1. This one's a little bit different than explicit. T of n plus 1 equals t of n. So again, that means next equals current, and then our common difference. So in this case, our common difference is 6. So that means we're adding 6 every time. Except one important part that we learned today is we have to tell them where to start. Otherwise they could start wherever they wanted. So in our last one, they gave us t of 1, which is our first term. That's why it was useful to find that. Our first term is 14. So we can say t of 1 equals 14. So with these two sets of information, they're now able to start their sequence somewhere and figure out what their pattern is every time.